Hey guys, this is part 2 of lesson 8.4, and we're just going to finish up. We just have a couple problems left, but they're longer problems, so I wanted to go ahead and start a new video. So we are going to talk about the last type of quadratic equation that you will have to graph, and it's really called two different things. So it's either called intercept form or factored form. And the reason it's called factored form is because it's usually always factored. The reason it's called intercept form is because that's the easiest thing to find. It will find the x-intercept. So I automatically know that my x-intercepts are, are 4, 0, because of this, and then 2, 0. So that's actually where I'm going to start to graph. So 1, 2, 3, 4, and 2, 0. Okay, so this, if I go halfway in between, that is going to be my axis of symmetry. So I know that my axis of symmetry is at x equals 3. So I have a lot of information. If I have my axis of symmetry, I also know that my vertex is going to be 3 something. So I'm going to plug in 3 and see what happens. So anywhere I see an x, I'm going to plug in 3. So I have 3 times -1, times +1. So I know that my y equals -3. So -3, or 3 -3 is going to be 1, 2, 1, 2, 3, is going to be my vertex. So I'm going to put that in the middle and fill out my x values. And then I'm going to find my y values. Remember, you only have to find 2 of the 4. The rest will pair up. All right, my graph looks really hideous, but I went ahead and just made the parabola. So we have the vertex, axis symmetry, table. Okay, let's talk about, concavity, it opens up. So that my domain, that's not going to change, but my range is going to be my y value of my vertex, so -3 and then to infinity. So I've got my domain and range, and my x-intercept I already found, so I just need to find the y-intercept. So I'm just going to say 3 times -4, because I'm plugging in 0 for x, and then -2. So 3 times +8 is 24. So my y-intercept is at 0, 24. And none of these ask for the max or min value. So let's go ahead and go through each of these and find that. So here, I'll do this in a different color. Here, this opens up, and so I'm going to have a minimum value at -8. So right there. For the standard form, let's see, right here. So that was going to be a max value at 5, right there. And then here, it opens up, so I'm going to have a minimum value at -3. And again, I'm getting it from that vertex. Okay, so let's go through this word problem. So what happens is, like, we are going to graph this on a graph where it makes a parabola. So as time is ticking on, if we throw something in the air, so like a ball or something, the ball's going to go up, 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 and then it's going to go down until it reaches the ground. Sorry, I was making that look better. That looks really bad. So, and everything is very symmetrical. So in a perfect world, it would take like exactly the same amount of time it takes to go up as it does to go down, and everything is just like perfect. So this is a formula that we're going to grab out of here. And so this is what I want you to see. The initial velocity, that's this. So we're going to be looking for that in the problem. And the initial height is there. So let's go ahead and t, that is going to be in seconds. And so this y-axis, that's going to be your height. And that's going to be in feet. So I think we set up the problem. So let's actually, the problem kind of starts here. So if a ball is tossed upwards with a velocity of 64 feet per second, so that's what's going to go there. Let's go ahead and fill that in. From a height of 5 feet, when, so time, does a ball reach its maximum height? So right here. So what it's asking for, oops, what is at, goodness gracious. What is asking for is this value right here. So what is the x value of your vertex, or the t value of your vertex? So when does a ball reach its maximum height? What is a maximum height? So this is going to be the y value of your vertex, or h in our problem. So really, we need to find the vertex and then apply it to answer the questions. So you know how to find the vertex. So this is in standard form. So we're going to use the axis of symmetry formula and start there to find the vertex. So go ahead and do that. Okay, so I did the axis of symmetry, and I found that my x value is going to be 2. So that is how long it takes for the ball to reach its maximum height. So when does a ball reach its maximum height? At 2 seconds. Okay, so now I'm going to plug in 2 into my formula for t and figure out what my answer is. So go ahead and do that. Okay, so you should have gotten 69. So let's go ahead and answer the question. When does the ball reach its maximum height? We've already done that at 2 seconds. What is the maximum height that is reached by the ball? And it's going to be 69 feet. And that is it.